Okay, so here's another moments question with another non-uniform rod. So trying to find things that are a little bit different. So we've got a non-uniform rod of mass 5 kilograms. So we know we're going to have 5G going down somewhere, but it's not in the middle. And rests with one end A on a rough horizontal ground. So straight away we see that. We've got our R, and we're going to have some friction. The centre of mass of the rod is d meters. So we know that this is going to be d meters away. The rod is held in limiting equilibrium by angle theta. The line of action of P, so that's a force, is the same. Okay, fine. So now we just need to resolve some forces, because remember I'm going to do up, down, moments at A. So the only thing I don't have an up, down for is this one over here. So I want to figure out what this is. Now we can see if that's theta, then using your sort of either your angle rules, you know that that's going to be the same as this one over here, right? If you need to see why, I can show you. So if we imagine you had your Z angle, right, or your alternate angles, this bit here would also be theta. This bit is 90, so this bit here would be 90 minus that theta. And then you've got, if you like, another 90 here. So then that bit there and that bit together make 90, so it's the same theta, if you could only think of it in that way. But hopefully you can see that's the case. So this is opposite, so we get P sine theta, and we've got P cos theta. So now we've got everything we need. And we do the exact same process like we do for ladders. We're going to have up equals down, left equals right, and then moments at A. So up equals down is going to be R plus P cos theta equals 5G. Left equals right. We're going to have friction equals P sine theta. And then we're going to take moments at A. So if we start at A, the first force we come to is 5G. 5G is this much away. And remember, this is the adjacent, so it's going to be cos. So we're going to have 5G times d cos theta equals, because obviously if I'm holding it, if my point is here, that 5G is going to push the rod down, whereas the P is going to push the rod that way. So one is going clockwise and the other is anti-clockwise. So P is already at right angles here, so it'll be P4 or 4P. So that's taking moments at A. And that's without me even reading through the question. What is it asking for? It's asking for the magnitude of the vertical component of the force on the ground. So essentially it's asking me to get an expression for R and for FR. Okay. And in terms of D, G, and theta. So we're going to have lots of things in that. Right. So if I'm going to rearrange this equation here to make R the subject of the formula. And then I can figure out what I'm going to substitute in. So R equals 5G minus P cos theta. Now the thing I want to get rid of is the P, but I don't want to introduce a friction. So I'm going to use this formula to replace P with, to substitute in for P. So if I rearrange this, P equals 5G d cos theta over 4. So if I substitute that in, I've got R equals 5G minus 5G d cos theta over 4 multiplied by cos theta, so that's going to become cos squared. It looks really ugly, but that's what they want. I've got something in terms of d, g, and theta. My friction is the same as P sine theta. So 5G d cos theta sine theta over 4. And those are my two expressions. They're not very pretty, but those are the answers. Now we're told that tan theta is 5/12. So if we take this over onto the other page, and that and we've got a coefficient of friction here. So let's copy that over. And let's see what that's going to come out to be. So we've got, given that tan theta equals 5/12. So now draw your triangle out if you need to. So tan is 5/12, so it's a 5, 12, 13 triangle. We might need it. And we're told that the coefficient is a half. So we know FR equals a half R. Okay. We have expressions for everything now. So we already have an expression for FR. This is what we did before. So we have FGD cos theta sine theta divided by 4. We have R, which we worked out to be 5G minus 5GD cos squared theta over 4. And now we want to rearrange this for D, but let's see what we can cancel out. I'm going to multiply both sides by 4. So that's going to give me 5GD cos theta sine theta equals, that's going to become 2. So that's going to give me 10G minus 5GD cos squared theta over 2. And now I can see what's inside everything and cancel out to make the calculation easy to then be able to use the tan theta. So what do we have on in everything? We've got a G in everything. We can get rid of that. And I think that is all for the moment. That's obvious. I could divide through by, no, I can just replace things. It's probably easier. So if I replace everywhere that I have, so remember tan theta is 5. So everywhere there's a cos theta, I can replace it with 12/13 and sine theta with 5/13. So I get 5D times 12/13 times 5/13 equals 10 minus 5. Actually, we can put that all as one fraction, so make that 20. Time 5D times 12/13 squared. So I want all the D's on one side. If I clean that up, I'm going to end up, I can stick it all into my calculator, she says, without a calculator in front of her. Sorry, as you can tell, I'm working these out with you. I have the final answers, but not the work solutions, which always makes it easier to explain so you don't assume anything. So you've got 300 over 169 equals 12/13 squared times 5 divided by 2. So I know I separated it out, but I should not have. So 360 over 169D, and that's got a D there. Put all the D's on one side. So if I add 360 to, I'm going to get 660 over 169D equals 10. So D equals 10 divided by so I'm going to multiply by 169 over 660, and I get 169 over 66, which is the solution. Okay, so that was a bit of a messing around with algebra. That algebra bit would probably only be worth 1 mark though, so you know your marks are for getting essentially to that point. Hope that's useful.